All right, on to for day 2 or part 2. How can I find reference angles? One of the most important things going forward is going to be reference angle. You understanding what a reference angle is. So if you think about angles, we know a lot about those. A reference, if you reference something, it has something to do with important information. So it's like a frame of reference or a point of reference. So we're going to be thinking about always what our frame of reference or point of reference is, which is always going to be x-axis, how far away am I? So reference angle is a whole lot kind of like thinking absolute value. So we're going to go do kind of our important definitions. So if you can go into your little vocab spot here at the very beginning of the section, it says what's a reference angle. Here's what a reference angle is. Let theta be any angle in standard position. Its reference angle is the acute angle, and they're going to use this theta prime, so theta with the little kind of like the feet symbol there, formed by the terminal side of the angle and the horizontal axis, which we normally call x. So some really important things about reference angles. They are always acute, that means less than 90, and it's always the distance to the x-axis. So distance to the x-axis. And since it's a distance, that means it's always positive. So some things to think about. These are really important. So it's always acute. They are always distance to the x, and it's always positive. Because if you draw an angle, so I'm just going to draw one here. What if I draw, let's draw 150 degrees. So 150 degrees in quadrant 2. If I asked you, hey, what's the distance? What's the reference angle? You could measure to the x-axis and figure out what that was. But what if somebody went to the y? That wouldn't give you the same answer, would it? Because if you're at 150, how much further do you have to go to get to 180? Well, 30 degrees. How far back is it to the y-axis? Well, that's 60. So that's not the same thing. So we have to have a standardized way of doing this. So we're always talking about the same thing, and that same thing, that standard, is always to the x-axis. And it's always positive, so it's 30 degrees more, and it's always acute then. In other words, think of it as like the shortest distance back to the x. So that's why I'm picking the 30. I'm not doing this, right, to get back to the x-axis and saying it's 150, right? So it's always the acute angle, so less than 90. So acute, distance to the x, and positive. So here's what we need to do. We need to take a look at each quadrant and figure out how would you decide what the reference angle is to answer that question. So I'm going to do kind of an example for you. For each one of these, and then we'll talk about like sort of the format for each one as well, so we can tell. All right, what if you are in quadrant 1 and this is your angle measurement? All right, so say 50 degrees. What is the shortest distance back to the x-axis? This is your terminal side. Well, it's 50 degrees. Like it's exactly the same as the angle. So in quadrant 1, the angle is equal to the reference angle. So the theta is actually the same as the reference angle in quadrant 1. So if you had a 50-degree angle measurement, so I actually put an number example in there. So if this were actually 50 degrees and I ask you what's its reference angle, what's your theta? How far is 50 away from the x-axis? The shortest distance is 50 degrees. They're exactly the same. So in quadrant 1, life's kind of easy. All right, let's do quadrant 2. So I'm going to draw an example of an angle that's in quadrant 2. So here's my angle theta. It's in quadrant 2. Okay, where's the reference angle? Let's draw it. So in this last one, my reference angle, I'm going to do reference angles in red for reference. In quadrant 2, the reference angle is the distance from the terminal side to the x-axis. So the reference angle is actually this angle right here. This is my theta prime. How would you calculate that? How would you figure out how much further you have to go to get to this location, the x-axis? Well, remember our 150 example? We had to go 30 degrees more. How'd you get that? Well, it's 180 minus the angle. So our reference angle in quadrant 2 is always going to be 180 minus the angle. Or if we're dealing with radians, it would be pi minus the angle. So it's like, how much further do I have to go to get to that x-axis? So we're always thinking about that shortest distance, the acute distance, back to the x. All right, what about quadrant 3? So let's go ahead and draw ourselves an example of an angle in quadrant 3. So here's my theta. Okay, where's the reference angle if you're in quadrant 3? Well, again, it's the distance from the terminal ray to the x-axis, the shortest distance. So not over here. We're doing the shortest distance, the acute angle. So the reference angle would be this theta prime. I think it's really helpful to have the picture so we can look at that and see what we're talking about. So how would you calculate that? Like how far past 180 did you go? Or pi, I guess, if you want to think radians. Say this angle theta was 200. How far past 180 did you go? 20. Well, how do you figure that out? You subtract. So your reference angle, though, now is the angle measurement minus 180. You went past 180. Or if you're talking about radians, it would be the theta minus pi. So we're always thinking about where are we? What are we comparing to? Okay, how about quadrant 4? Like 300 degrees, something like that. So the terminal side puts you all the way into quadrant 4. That's your theta. So where would the reference angle be? The shortest distance back to the x. So between the terminal side and the x-axis, that's that theta prime that we're talking about. So this angle measurement right here, acute shortest distance back to the x. Well, say your angle was 300. I'll use that as an example just so we can have something to think about. How much further is it till you get all the way around to 360? 60 degrees. Okay, so how did you figure that out? Well, 360 minus 300. So your reference angle, we're not comparing now to 180, we're comparing to 360, or do you remember what that was in radians? All the way around one rotation, 2 pi. So you're doing either 360 degrees minus your angle, so like 360 minus 300, or you're doing 2 pi minus your angle if you're in radians. So we always have to be comparing to what's the closest x-axis. So depending on what quadrant we're in, it might be 360 or you might be comparing to 180. So we really do need to keep track of that to know what our reference angle is going to be. So let's practice a few. So that's what we're going to spend all of today on, is just making sure we can deal with, oopsie daisy, reference angle, and then we'll be able to do some things on our calculator as well. All right, so for the first one, we're going to find the reference angle for 210. So if my original angle is 210, I'm going to draw each of these because I think it's really helpful. First thing to think about is what quadrant is 210 in? So that's a quadrant 3, right? Because we're past 180. So I'm going to draw 210 degrees. And remember your directional arrow there on the inside. So I'm going to ask you to draw where the reference angle would be. So from the terminal side back to the x-axis acute, this is the reference angle that I'm talking about, and that's the number I need you to be able to calculate. All right, so if I'm in, whoopsie daisy, that's a really weird equal sign. My reference angle, so theta prime, my reference angle in quadrant 3, I'm going past 180, so I do theta minus 180, or the angle minus 180. So I'm going to take 210 minus 180. In other words, how far did I overshoot 180? Well, I went 30 degrees past, so that would be a 30-degree reference angle. That's what I need you to be able to calculate. It's really important. So just know what quadrant you're in. All right, well, I'm going to erase this. Let's take a look at 4.1. Here's where things get a little bit interesting. 4.1 what? So what units is that being measured in? What don't you see? I see no degree symbol, so this is in radians. What's really hard for people is trying to recognize and get comfortable with radian measure and knowing where it is. Because don't we need to know what quadrant that's in, right? So we know how to calculate the reference angle. So where would 4.1 be? If you look back to that radian picture that we did, if you remember the arc length that's equal to the radius of the circle, remember halfway around the circle was pi, or 3.14, or 3 arcs plus a little bit more. So we had an arc, and then we had another arc, and we had another one, and it stopped just shy. And then we had another arc, which would be 4. So this is 1, 2, 3, 4, 5 put us somewhere over here. 6 was about there, and then we had a little bit left. So we think about radians. And all the way around was 2 pi. 2 times pi, that's 6.28. If you think of these as your benchmarks, get that kind of wheel back in your head, we can have a good idea of where 4.1 is. Where is 4.1? It's going to be in quadrant 3 for sure. Another way to figure that out, we could just actually do the calculation for pi over 2. So just take the number pi and divide it by 2. So try that in your calculator. Believe that's like 1.5 something. 1.57, I think. And then do you remember what the value was down here? 3 pi over 2, right? So 3 90-degree intervals. 3 pi over 2 is about 4.71. So have those numbers, those decimal values in your brain so we can tell, okay, how are we going to calculate this reference angle? All right, so let's do my angle measurement then. So 4.1, oops, let's do it in green. So my original angle, so it's going to be at 4.1, just we'll say about there. So that means that's my theta. So my reference angle then is the distance from this terminal side back to the x-axis. That's going to be my theta prime. So again, we're in quadrant 3, so we're looking at this one. It's theta minus pi. So the angle minus pi. So to find this reference angle, I'm going to be doing my angle measurement, 4.1 minus pi. I overshot it. In other words, it's bigger than 3.14, right? So if your decimal number is bigger than pi, you must be bigger than quadrant 2 for sure. All right, so we're going to go ahead and subtract those two, and we can get our reference angle. So it's about 0.95. I'll just go out to 4 places, 8/4. It's not going to be an exact answer because pi doesn't stop, doesn't repeat. So knowing your quadrants, where it's at. All right, let's do a few more. Let's do the next 3 here. So I want you to try to draw it. If you want to pause the video first, see if you can figure out what it is. We'll talk about some strategies. All right, so 300 degrees. So 300 degrees is my first angle measurement. So 300 degrees is in quadrant 4. All right, so can you draw the reference angle for me? So it's the distance from the terminal side back to the x-axis. So that's the theta prime that I'm talking about. So how am I going to calculate theta prime if it's in quadrant 4? Go back to my pictures. 360 minus the angle. In other words, how much further do I have to go to get to 360? What's the distance from 360? So 360 minus 300, my reference angle then would be 60 degrees. So how far away am I? Always positive, always acute, shortest distance back to the x. Okay, how about 2.3? What units of measure is 2.3 in? 2.3 radians. No or no degree symbol, so I know it's in radians. So you have to figure out what quadrant would 2.3 be in when I draw this. Okay, now remember halfway around the circle is pi, 3.14, starting here. Do you remember what that number was up there? 1.57, so where would 2.3 radians put you? Between 1.57 and this. Remember, if we do our arcs, the first arc went to about here. 1 radian's about 60 degrees, pretty close. Second arc puts us into quadrant 2 for sure. So we know that this is a quadrant 2 angle. So when I draw it, quadrant 2, we'll guesstimate here, this is our theta. Okay, so where's our reference angle then? So this was in quadrant 2. Distance between the terminal side and the x-axis is our reference angle. So how do I calculate, oh, not Q, that's for quadrant. How do I calculate my reference angle, my theta prime? Let's go back. Quadrant 2, right over here, quadrant 2. I should have put this the other way around, 1, 2, 3, 4. That maybe would have made sense to people. In quadrant 2, it's 180 minus theta, or pi minus theta, the angle. So I'm going to do pi minus 2.3. Think of it this way. Pi is bigger than 2.3, right? So we're going to be subtracting from pi. We should get that positive angle then. All right, so pi minus 2.3. Go ahead, try that. I'm going to go to 4 places again. So 0.84. Can't read my rating. I think it's 6.6. All right, so radian measure, just be careful. Make sure you know what quadrant you're in. Okay, last one. This can be hard for people. It's a degree measure. Remember what negative means when you graph it. Negative just means that you are going in the opposite direction. So instead of counterclockwise, you're going clockwise. So negative 135 is going to put you about right here. Now, what's hard for people then is thinking about like the sign and being able to calculate. I think it's still easy to say, okay, here's my reference angle, terminal side to the x-axis, so that's going to be my theta prime. Now, in quadrant 3, we usually do our 180 or angle measurement minus 180, but those were where the thetas are positive angle measurements only. So you have a couple choices. Some people can kind of just look at this and figure it out. If I went 135 degrees already, how many more would I have to get to negative 180? You can think negatively, and that's fine, as long as you're still a positive person, right? But if you're thinking negatively, how much further do you have to go? Well, what's the difference between 180 and 135? Well, you're 45 degrees away. So a lot of people can do it that way, and that's fine. If you want to use sort of the formulas that we talked about, so we're in quadrant 3, you do need to have a positive angle. So what you would have to do is think coterminally for a second. Remember what coterminal means? Angles that end in the same place. Do you remember how to find them? Well, you add or subtract 360. Since I'm in the hole, I want to add 360. Go ahead and add 360 negative 135. What is that the same as? 225 degrees. So you could also, to do this question, instead of thinking negative 135, you could think of positive 225, which most definitely ends in the same spot. And then our theta prime, our reference angle formula makes a lot more sense. So 225 minus 180 puts you at 45 degrees. So you really do kind of have options depending on what's the easiest way for you to think of that. But just remember, even though your angle measurement was negative, your reference angle is still positive because reference angles are always distance from the x. Distances are positive. Think of it like absolute value, distance from 0. It's just that 0 is the x-axis. So the distances from 0 are always going to be positive. Okay, our last little piece to deal with today is just making sure you can use your calculator if you're asked to evaluate any trig function, no matter if it's degrees, radians, whatever. So let's just double check. Be careful on your mode. So we always want to check the mode of our calculator to be sure we're okay. All right, so tangent of 119. So on the double check my mode here. My mode is in degrees. Good. So I want to do tangent of 119. And I get a negative value. Okay, so negative, and we can decide what we want to round to here. So we're going to say, where's my value so I can jot it down? Oftentimes they'll have you go to 4 places for these. Now, does it make sense to you that 119 gave you a negative answer for tangent? What quadrant is 119 in? 119 is before 180 but past 90, right? So we're in quadrant 2. Are tangents negative in quadrant 2? Absolutely. Negative slope, right? The y's are positive, but the x's are negative. So it should be a negative answer. So think about reasonableness when you're using your calculator. We all type stuff in wrong. Think about what it should be. Okay, now a little bit to think about on this one. Cosecant of 5. What units are the 5 in? No degree symbol, so that's radians. So when we're doing this, this is in radians. So right away, if I'm going to use my calculator, I better switch over my mode into radians. So let's be careful there. So let's switch over to radians. So I know I have radians. Now the next thing, how do you type cosecants? There's no cosecant button on your calculator. Well, which one is cosecant or reciprocal for? Sine. So this is going to be the same answer as 1 over sine of 5. So cosecant of 5 radians is equal to 1 divided by the sine of 5. So when I type this in, I'm going to do 1 divided by sine of 5. Now remember, I switched it to radians. So the calculator is assuming that they mean 5 radians. And I'm getting a negative number, negative, and we'll go ahead and jot this down, negative 1.0428. Okay, now where is 5 radians? Can you tell me what quadrant that's in? 5 radians. Remember our arcs. So when we think about the radius being the arc of the circle, we had 1 and then 2, 3, right before 3.14. And then we had 4 down here. 5 was about there. 6 was about here, and then all the way around is 2 pi or 6.28. So I think keeping this wheel in your head. So 5 is in quadrant 4. Okay, what do you know about sines in quadrant 4? Remember, it's the y value. What do you know about y's in quadrant 4? They're negative. So guess what? 1 over a negative number, still going to be negative. So when you see this answer, don't be surprised. Make sure you understand why it is that way. So what's reasonable? So thinking about this, it looks like a very easy thing to do, but we need to understand what's happening. All right, last one. Let's do cosine of pi over 5. So again, what units is that in? Pi over 5. What don't you see? Degree symbol, right? So this is still in radians. Now cosine is something that we can just type, so we should be able just to type this one in. So cosine of pi divided by 5, and we're getting round this one to 4 places, so 0.8090 it looks like, and it ended up to be positive. Where would pi over 5 be? So pi over 5, that means taking pi, which is all the way to here, into 5 equal chunks. So like 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 chunks, one of them. So where is that angle located? Well, that's definitely a quadrant 1. You could do 3.14 divided by 5 as well, and you're going to see it's a number less than 1.57. So we're in quadrant 1. So does it make sense to you that cosine or the x is positive? Sure thing. Always think about where you are. What's reasonable? Where are these values going to be? So big picture today is all about reference angles. How can I find a reference angle? So the three big things, they're acute, it's the distance to the x-axis, shortest distance, and it's always positive. So be able to find reference angles and use your calculator.